to two projects. In this video, we are going to explain about the project, which is Personal Protective Equipment Detection for Construction Workers, a novel dataset and enhanced YOLOv5 approach. Before getting into the execution, first let us understand what is the project about. In the construction industry, worker safety is the top priority because these sites can be very hazardous. We have regulations that mandate the use of personal protective equipment. So there is the need of personal protective equipment like hard hats and reflective clothing because they will keep the workers safe. But the issue is even with these rules, many workers don't comply, often because they are not convenient for them. They might not fully understand the importance of the safety, or there is a lack of proper supervision to ensure everyone is following the guidelines. Traditional manual monitoring approaches, so the traditional way of monitoring compliance has been manual, which is just isn't efficient, especially on the large and constantly changing construction sites. This means that we might not catch every instance where workers are not wearing their PPE properly, that is, personal protective equipment properly. As a result, this inconsistency can lead to serious safety risks. We need a more effective system to ensure that everyone is using that right protective gear at all times to really enhance safety on these job sites. So, coming to computer vision, it has become a valuable tool for automating the detection of personal protective equipment. This helps to improve the safety and also the compliance for workers on construction sites. However, we have noticed that many of the systems out that these primarily focus on detecting hard hats, they neglect reflective clothing. So this is a big oversight since reflective gear is essential for ensuring visibility and also preventing accidents, especially working in the low light conditions. So the challenge with detecting reflective clothing lies in its deformable features, which can make it tricky for models to identify accurately. Plus, the datasets used for PPE detection often suffer from imbalances like the diversity needed to train effective models. This really limits how well these models can perform in the real world. So, addressing these issues is crucial if we want to ensure reliable and comprehensive PPE detection across the varied environments we see in the construction over work. So, in this project, we are focusing on the enhancing the detection of personal protective equipment. So, our proposed system uses a new data set that will capture the four categories of the data set. So our proposed system uses the new data set includes of four categories of PPE. So it captures the four categories of PPE like hard hats, reflective gear, etc. What's great about this data set is that it captures accurate real world samples, which is crucial for training our model detection. We made sure that the dataset can handle all the types of challenges such as different lighting conditions and varied backgrounds. This is particularly important when it comes to recognizing reflective materials, which can be tricky to identify under different circumstances. So, by tackling these issues head on, we aim to significantly improve how we detect PPE and also ultimately enhance worker safety on construction sites. In this project, we are incorporating YOLOv5 algorithm to detect the PPE, whether the people are wearing PPE or not. On the key upgrades in this edition, as in attention mechanism. So attention mechanism is incorporated, which will help the model concentrate on specific areas where PPE is likely to appear. So this makes it more efficient at recognizing protective gear in complex environments. And we also have incorporated loss function. So we have incorporated loss function. This will better manage situations where bounding boxes overlap, which can often lead to confusion for detection models. This upgraded version of the model is called AL YOLO V5. And we put it thorough rigorous testing to ensure it really makes a difference. What we have found is that it reduces false detections and boosts accuracy, especially cases where multiple objects might be close together. So these enhancements collectively make our system more reliable for monitoring PPE compliance, which is crucial for creating safer worker environments. By improving how accurately we can detect necessary protective gear, we're helping to ensure that workers are better protected on the job. So as an extension, to further increase the accuracy of this project, to further increase the Detection accuracy, we are incorporating advanced versions of the YOLO, which are specifically YOLO V5 X6, along with the latest versions that are YOLO V8 and YOLO V9, to really enhance the object detection capabilities. This upgrade will help us analyzing PPE on construction sites with greater precision and reliability. On the top of that, we have developed front end using Flask framework. So this will allow us to conduct user testing with built-in authentication features, making the system more secure and user-friendly. With this integration, we will be able to facilitate real-time monitoring of PPE compliance, ensuring that we can effectively manage safety on site. Moving on to the implementation of the project, we have followed the steps in the flow of work. So first, what we have done is we have imported the packages. So this step involves bringing all the necessary libraries and packages required for data handling. And then we load the data set, we load the images from the data set into the program for analysis. We visualize the loaded images to understand their content and the quality. And then we do some basic pre-processing, that is image processing, where we transform the image into a format suitable for model input, which is often a blob, that is binary large object. And we set up the classes that the model will recognize, such as hard hats and reflective clothing. And we specify the bounding boxes. We specify the object locations that are located in the image, that we call them as bounding box. And we change the image data format into a NumPy array for easier manipulation and processing. Then we give we access the architecture of the pre-trained model to understand its structure. And we identify and prepare the output layers that will generate the predictions. And we annotate files where we combine image data with the corresponding annotation for training. And we change color format of the images, that is BGR to RGB. BGR is nothing but blue, green and red, and RGB is nothing but red, green and blue. And we generate a binary mask to identify the objects within the image, and we adjust image sizes, image dimensions to match the input requirements of the model. And we do basic data augmentation where we apply random transformations to image to create a variability in training data. And we rotate images at various angles to help the model learn to recognize objects in different orientations. And we apply other transformations like flipping, scaling, or adjusting the brightness to enrich the dataset. And we ensure that all the necessary libraries and dependencies are installed to avoid runtime errors during the execution. And we prepare the data and format the dataset specifically for the use of YOLO, that is You Only Look Once object detection models. And we create the architectures of the model, that is YOLO models, by defining its layers, activation functions, and connections. And we use prepared data set to train the models, allowing it to learn from the input data and improve its detection capabilities. And we save the best performing model. We save the best performing model to disk for the later use, ensuring we can load it to make predictions without retraining the model again. And we set up the web interface using Flask, incorporating user registration and login functionalities that can connect to SQLite 3 database. And we utilize the data set. We utilize the train model to classify the detected objects based on the user input through the front end. And we allow users to input the images they want to analyze for PPE detection on the construction sites. And we prepare the uploaded image for model by applying necessary pre-processing steps such as resizing and normalizing. And then leveraging the previously trained model to make predictions on the pre-processed image. And the results will be shown in the front end. Show the results of the detection process through the front end, through the web interface, highlighting identified objects and their locations in the uploaded image. Moving on to the algorithms used, these are the algorithms used in the project. The last three are the extension models used in the project. And this is the proposed model. Moving on to the requirements. These are the basic requirements which are needed to implement the project. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now to execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of a project. Let us understand them. How will they be used in the project? In the sample folder, we have images. These we will be using them in the front end to detect the PPE. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Here we have model file which contain the algorithm information, and this will be loaded into the project code during runtime of the application. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. And here in the first three folders, we have the data set in it. Let us open this first folder, that is YOLOv5 folder. So here we have two subfolders. One is test and other one is train. Let us open the train folder. So here we have two subfolders. One is images and the other one is labels. Let us open the images folder. So in this, we have total 1201 images. So here we have total 1201 images. These images are used to train the YOLO models to detect the PPE in the image, that is construction sites. So get back. So for the images in the image folder, in the labels folder, we will be having the annotation files. So let us open the labels folder. So here we have files containing annotations or the labels for the objects in the corresponding images. So here, each label file, it corresponds to an image file in the image folder. So this first label file, it corresponds to first image file in the image folder. Similarly, the second image files object locations are in the second label file. So this provides the object locations and the classes within the image. So for all the total 1201 images, here we have 1201 label files. Let us open one file. These label files, they follow the YOLO format. Here, a line represents a detected object in the image. So this line follows the YOLO format. Here, this line, here we have the object class index followed by its bounding box coordinates. So this is the X limit, this is the Y limit, this is the Y limit, and this is the width, and this is the height. Close this. Similarly, we will be having in all the 1201 annotation files. Let's get back. Similarly, we will be having the test folder also. So here we have images and the labels. These we will be using for testing the models, that how well the models have been trained in detecting the PP in construction sites. Let's get back. Accordingly, we will be having the same images in the YOLO V8 and YOLO V9 folder, but they will be annotated differently because each YOLO version requires the own specific type of image annotations for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensures that each YOLO version receives the correct annotations it needs to function properly. So now let's execute. Now copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open the Anaconda prompt. So it is open. Now use the command cd followed by the space, paste the copied path and now click on enter. Here if you observe, current directory is changed to the code folders path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. So this will change. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So let's wait, it is being run. So here we got, this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. Let's register first. Click on register. And here we need to enter all the registration details if we are registering newly. I have already registered, so I'll directly sign in. So click on sign in. Provide your username and the password. Click on login. We have logged in successfully and we are redirected to detection page of the project. So here you can see a choose file button, right? We need to click on that for uploading the images. So click on choose file. So these are the images that we will be using in the front end to detect the PB in the construction sites. And this is in the sample folder of the main code folder. So let's upload the first image. Click on open. It is loaded. Now click on upload. This image will be processed at the backend and then train model will be giving us the detections. So here the train model has given the detection that here other clothes have been detected with the blue color bounding box with the 0.79 probability score and with the class label other clothes. Probability score is nothing but it is the confidence level that how accurate the detection is in detecting this specific class. So here we can observe that the lady is not wearing the protective equipment, that is PPE, personal protective equipment. She has to wear that. So this application is detecting that the lady is wearing the other clothes. Let's get back, try uploading some more. Click on choose file. Let's upload this image, upload it. So here if we observe, a person has been detected. He is not wearing the helmet. So that is why it has labeled as person and it is detected in the white color bounding box with a 0.73 probability score. He is not wearing the personal protective equipment where he has to wear the helmet. He wore the reflective jacket, but he's not wearing the helmet. Let's get back. Click on choose file. So now let us upload this image. Click on open and now upload it. So here we can see the detection a hat has been detected. So it is detected in the blue color bounding box with a 0.77 probability score. Here if we observe, this person is wearing the personal protective equipment. So this person is following the guidelines. Let's get back and try using some more images. Click on choose file. Now let us upload this image. Click on open. It is loaded. Now upload it. So here we got the prediction that a person has been detected with the 0.68 probability score. Let's get back. Let's upload some more. So let us upload this image. Upload it. So here we got the prediction a person has been detected with a 0.74 probability score and he is not wearing the PP, that is protective equipment. He has to wear that. So the application is detecting that person is not wearing that PPE and he's just the person. Let's get back. Click on choose file. Now let's upload this image. Click on open and now upload it. So here if you observe other clothes have been detected. Let's get back, try using some more images. Click on choose file. So let's try uploading this image. Here, if you observe, there are two kinds of detections. One is three hats detected, and we have three reflective clothes detected. So these people are wearing the PP, they're following the complete guidelines. And we have their respective probability scores and their class labels. Get back, click on choose file. Let's upload the last image. So let us upload this image. Click on open and now upload it. So at this particular construction site, people are wearing their reflective clothes. So they are following the PPE. Get back. Now let's check with the graph. So click on graph. So here the first graph which we have is precision and recall graph of YOLO model, that is YOLO algorithm. Here on x-axis we have recall score and on y-axis we have precision. Here each color represents each type of class. Moving on, here we have F1 score graph where on x-axis we have confidence level and on y-axis we have the F1 score. And here we have the confusion matrix of the YOLO algorithm where here we have the actual predictions and on y-axis we have the predicted predictions. And here we have precision comparison graph, where on x-axis we have the algorithm name, sorry, precision score, and on y-axis we have the algorithm names. This is the recall comparison graph, and this is the mean average precision comparison graph. Mean average precision, recall, and FN score, precision, recall, and mean average precisions are the error metrics used to evaluate the detection models. Now let's click on logout. In this way, by using YOLO models and by uploading images to the application, the YOLO model, they will be detecting whether the people are wearing PP, that is protective equipment, or not in the construction sites. So this will benefit both the construction people and also the workers who are working in the construction sites. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.